All right. So there's a theme in what we're doing. We're going to be asked to graph all of these functions. So there's a bunch of functions. The first one is f of x equals x to the first power. And then we're going to do f of x to the second power, third power, fourth power, fifth power, all the way up to f of x to the sixth power. What I want you to observe is odd powers of x and the even powers of x. There's a pattern that will emerge. So remember that odd numbers are 1, 3, and 5, and that the even numbers are 2, 4, and 6. Okay? So the first thing we're going to do is we're going to graph f of x to the first power. Okay, so take your calculator and just put an x in there. Well, bam. Hit zoom, and then we're just going to do zoom standard 6. Okay? Now, Mr. Adams is going to take a little screenshot of that. Somewhere. Yes. A big. Bring your calculator here. Just grab a different calculator. I'm going to reset this one. Okay. So I'm gonna copy and paste that graph over here a little bit. I'm just gonna make a tiny version of it. Do I want you to sketch the graph? Yes. Just kind of push it over here to the side. Okay. Now the question is, what is the domain for that? Well, the domain for this is what values. Does anybody remember what domain means? Yeah, it's all the possible x values, right? So the maximum comes into it, like what's the minimum and what's the maximum and the stuff in between. Are there any domain restrictions, basically? And the short answer is no. There's no domain restrictions. I can plug anything in for x, right? And so what do we say if it goes from negative infinity to infinity? What can we say the domain is? Well, we could just say that, right? We could just say that the domain, I don't know if you remember this, this is something we learned at the beginning of the school year, that it goes from negative infinity to positive infinity. And sometimes we'll say all real numbers, or sometimes you'll hear mathematicians say all reals, right? All real numbers. What about the range, right? And let's put this here. The domain is the x values, and the range are the y values. So now the range is what can I plot? What are my y values? Is there a restriction? Well, the answer is no. There are no restrictions on the y value. It can go all the way from negative infinity to positive infinity. And so we would say all real numbers for all reals. And so now one thing that, and I'm going to word this a little differently, we're going to study the end behavior of the graph. It says as x approaches positive infinity, that means we're going to go to the right. It's saying what, as we follow the graph to the right, in other words, as I go this way, what does f of x, and remember f of x is the y value, what does the y value do? It approaches positive infinity. Well, what happens if I go to the left? It approaches negative infinity. Now, what I do want to point out is that it starts on the bottom and ends up in the top. So if we read this left to right, It starts on the bottom and ends up going out the top, right? That's important. Keep that in mind. Now, what's the next thing we got to do? First of all, do you guys have this written down? Almost? Okay. Now, what you guys don't know is that problem that we did, that last problem from the SAT prep thing, we can use this type of information to help us get the answer quickly if we know what the graph looks like. It was a third-degree polynomial. They gave us some zeros. We should be able to predict or write the equation based on the graph. Okay. All right. So the next thing we need to do is we need to graph f of x equals x squared. So go back into your graphing calculator, go back to y equals, and just on the end tack on the 2. Now let's graph. And so now we have a parabola. Duh, Mr. Adams, we know what that looks like. We spent a lot of time. You talked about it for days. Good. So that's a parabola. Let's copy and paste that or sketch that in over here. Oh, we don't want to do that. Now I'm just going to throw that in right over here. Okay. So again, and so let me write this down. I'm going to put some additional things. For this one, put odd power of x. And so because this is 2, we would say that this is an even power of x. Okay. Now for the domain, it says what values can I plug in for x? Well, there are no restrictions for x, so it still goes from negative infinity to positive infinity in the x direction. Okay. However, on the range, am I ever going to have a negative y value? No. The shape of the graph never goes below the x-axis. So my y value, I can have 0 because it passes through the origin. So I can include 0, but it's always the lower boundary will be 0. The maximum value for y would be infinity. Because we can include the 0, we use the bracket. Right? So as we read this graph to the right, my y value approaches what? Yeah, positive infinity. As x approaches negative infinity, in other words, as we go to the left, my y value also approaches positive infinity. So this one starts on the bottom and goes out the top. This one starts on the top and goes out the top. Okay? So I see you guys are writing frantically. So let me recap that while you're writing it down. This pattern is important. An odd power function always, as you will see, starts on the bottom and goes out the top. If the leading coefficient is positive, an even power of x, and we're talking about polynomials today, always starts at the top and goes back out the top, as long as there's a leading coefficient that's positive. Okay? You guys done? Can we move on to the next thing? Okay. So now I have x to the third power. That is an odd power of x. 3 is an odd number. What do you think we're going to do? Let's graph it. So I'm going to graph it. I'm going to come back in here to y equals, go to my little number and change that to a 3 and hit the graph. It's no accident. Notice that it starts in the bottom and comes out the top. If we read it like a book left to right, it starts on the bottom and goes out the top. You just use the cursor until you get to the 3. That's an easy way to do it. So this is an odd power. So we start down here in the bottom, and if we read it like a book left to right, we go out the top. No domain restrictions. In fact, all of these, the domain is going to be from negative infinity to positive infinity. What about the range? What's the range going to be for the y values? Negative infinity to positive infinity. And as you go to the right, it goes towards positive infinity. That's the going out the top. And as you go to the left, it approaches negative infinity. That's going out the bottom. So this is top, this is top, this is top, this is bottom. So we come in through the bottom and go out the top if you read it like a book left to right. Okay? That's, well, I don't want to say it's no accident. I used to have a professor that say, that's no accident, which is true. The numbers do certain things. Okay? So just to kind of recap, these are parent functions. We haven't transformed them. We haven't stretched them. We haven't translated them. We haven't moved them around at all. It's the basic parent functions. X to the first power, x to the second power, x to the third power. Coming up next is x to the fourth power. That is an even function because 4 is an even number. Not even function. Sorry, I misspoke. It's an even power. Yeah, technically, it's an even function, but it's an even power. Okay? It's an even power. Well, let's graph it and see what it does. So now I'm going to come in here, hit y equals. And if you just move the right cursor, it'll eventually put you where the 3 is. And you just hit 4, and that replaces the 4. Then you hit graph. What does that look like? Yeah, it kind of looks like x squared. It's a little different. It's a little different. That pattern will emerge too. So let's just paste it in here and see what we get. So it looks a lot like x squared, but it seems to be kind of flattened out a little, doesn't it? So again, there are no domain restrictions. You can have all real numbers. The x values go from negative infinity to positive infinity. This one comes in through the top and goes back out the top. In other words, as x approaches positive infinity, y, or f of x, approaches positive infinity. As x approaches negative infinity, y approaches positive infinity. Okay? Now, the range is restricted, though. There are no negative y values, but you can have a 0, so it goes from 0, including the 0, up to positive infinity. Okay. Our next thing that we have to graph is x to the 5th power. How do you think that graph will look? Huh? I don't know. Let's see. I guess we'll find out. So a student said it's either going to look like one pattern or the other, basically. So it is an odd power. The student observed that the even powers kind of have a U shape, which is true. All right, you guys ready to graph the next one? Let's jump into our graphing calculator. Go to y equals, use the right cursor twice, replace that 4 with a 5, hit graph. Okay. Hey, guess what it looks like? Yeah, the other odd powers. Now, the one that throws you off on in this scenario is x to the 1st power, because it's a straight line. And, well, that's okay. So, we don't want to do that. So what about this one? Where does it come in and where does it go out? Yeah, it comes in from the bottom, which is negative infinity, and goes out the top, which is positive infinity, right? So as x approaches positive infinity, f of x or y approaches positive infinity. As x approaches negative infinity, f of x also approaches negative infinity. If you read it like a book left to right, it starts on the bottom and works its way out the top. Again, there are no domain restrictions. The only time that we have domain restrictions is the square root or even root of something. It can't be negative. You can't have zeros in the denominator of rational expressions. For real numbers, I think those are the only 2 domain restrictions that I can think of off the top of my head. What about the y values? Any domain restrictions there? No. Range restrictions, not domain. Yeah, so it's all real numbers from negative infinity to positive infinity, right? Okay. So the next one is going to be x to the 6th power. That is an even power. So how do you think that graph will look? It'll look like a U. Oh, wow, we're diving in. All right. Well, not 0. You're talking about the range, right? My bad. Yeah. What about the domain? What do you think? Yeah. What about this? Positive and positive. So based on the pattern, the student said it should be U-shaped. The domain should be this. The range should be this. And as it approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches positive infinity. It will be U-shaped. It'll just be a little bit wider. Okay. So let's look at that. So hit y equals. Change that to 6. And let's graph it. Yep. Now, the reason this pattern emerges is whenever you multiply a negative number by itself, it becomes positive. So when you have an even power, you're multiplying a negative times a negative times a negative an even number of times, so it becomes positive. That's where that pattern comes from. If you compare these, as the power increases, you'll notice that it kind of widens the gap or the graph, right? I tried to make these about the same size. I'm going to zoom out in a second so you can see them all next to each other, right? So this straight line is a very wide line, right? But as on the odd function or the odd power functions, they get narrower and narrower. Well, actually, I think they get wider. I got to think that through. But if you notice on the even power functions, it changes the dynamic of the graph, and it's really hard to see with them back to back. So what I'm going to do is I plug this in Desmos, and I just want to show you a couple things, okay? So let me move my face over here. By the way, are you guys done writing this down or no? Is everybody done writing this down? Okay. So watch this. This is a times x to the b. A is 1. Remember I said that? Well, if I say b, this is x to the first power, right? We know what that looks like. This is x to the second power in real time. This is x to the third power. This is x to the fourth power. X to the fifth power. X to the sixth power. X to the seventh power. X to the eighth power. X to the ninth power. X to the 10th. And if I wanted to, I could change this. We'll do 50 and I don't know, we'll do negative 50 over here. That seems a bit high, but so now if I just keep changing this, what do you notice about the graph? Yeah, it does some interesting stuff, right? It switches from up and down. That's the even odd stuff. But if you look at the graph, I'm going to change it so you can only look at the evens. So I'm going to count by 2, so it'll only be evens. Watch this. So these are just the evens. As that power increases, it almost looks like a square, right? So this is x to the second power, x to the fourth, x to the sixth, x. So if I do this, it kind of looks like this. What do you think happens if I put a negative in front of it? What's going to happen? It'll flip, right, over the x-axis, right? So as I put that and make it negative, it flips, right? By the way, the pattern's still the same, but now it's just upside down. Now, if I change this to 1, and let me go to 3, now I change this back to 2. Now I'm just going to look at the, oh man, it won't let me do it. Shoot. I wanted to count by the odd numbers, but that's okay. So does that make sense? Kind of? All right. We'll stop there because now we're going to do